Okay, so this is a demonstration of the equivalent time sampling feature on this TDS 5104 scope. And I have in the scope one of these Leo Bodner pulse generators. This particular one produces a rise time of about 32 picoseconds. And I have its trigger out hooked into this auxiliary line. And it's triggering on that auxiliary line right now. And with this, I also have it measuring the rise time. And you're seeing like between 200 and 250 picoseconds. So it turns out with this particular signal, if I instead trigger directly on the signal itself, let me get rid of this delay, then the jitter that you were seeing kind of goes away. And I think you get better rise time measurements every now and then. You see it hop below 200 picoseconds. But anyway, this is basically sampling this, and it's drawing this curve using interpolation. That's what this IT means here. So essentially, if I go into display and I say show dots instead, you can see the dots that are being sampled. And as a matter of fact, if I didn't single shot it, you can see those dots are actually spaced about 1 per division. And at 200 picoseconds per division, that lines up with the 5 gigasamples per second that the scope can do. So that's what we're seeing, is it's actually sampling, like it says down here, at 5 gigasamples per second. So that's just normal, straightforward sampling. And the feature I wanted to show, let me put this back into run mode, is this equivalent time mode. If I turn this on to auto, then all of a sudden we have many more samples. And in fact, I think the rise time measurement might get a little better with it in this mode. Truth be told, this rise time is better than what you would theoretically get out of a 1 gigahertz scope. It's perhaps, if you do the math, it might be somewhere around like 1.5 to 2 gigahertz. So the scope is actually measuring a rise time better than it's spec'd. But the feature that's interesting is this, the fact that there's more samples. And if I single shot this, you can see that it's doing several acquisitions, 300 acquisitions. Let me do another single shot, 200 acquisitions. So it's doing multiple acquisitions, randomly filling in this curve. And this only works for repetitive signals. You can single shot these and, it'll fill in a lot of dots. And the scope claims, when it's doing this, that it's 250 gigasamples per second of equivalent time sampling. So that's roughly the feature. And it basically helps fill in, if you're not in equivalent time with this, you're essentially stuck with 1 sample every 200 picoseconds, and this kind of helps fill it in. And I think, for measuring things like this, it visually kind of fills stuff in, and it may make it easier for the scope to measure the rise times of signals like this. Okay, thanks for watching.